If imaginary numbers don't exist, then why do we learn about them? Now, the first point to make is that mathematicians don't call them imaginary numbers. That is just a name that was invented in like the 16th century when we didn't know what we were doing. Today, we call these complex numbers. But now, to more directly answer the question, I'm going to give 3 arguments for why I exist. My first one is that anything consistent exists. Chess exists in the world of ideas, right? Star Trek exists, again, in the world of ideas and in mathematics. Anything that is consistent has precise rules about how they work and behave. As long as they don't contain a contradiction, it exists. Second point, we need I. In fact, I makes algebra make more sense. If you don't have I, it's hard to figure out some problems. It actually makes geometry, something really physical like geometry, makes more sense with I. Calculus, differential equations, and in fact, I don't think there is a subject in mathematics that isn't improved by having I. But even historically, when we didn't understand I, we were suffering, right? Medieval people suffered pestilence and famine, and they suffered the lack of I. That's actually really sad. And the last point I'll make without getting too much into the details is that in fact, geometry makes I make sense. In fact, plenty of mathematicians think that rather than calling them imaginary or complex numbers, we really ought to call them geometric numbers, because effectively what's going on is that you can take any complex number, have a part of it that's just a pure real number, right? It has no I stuff in it. A part of it that is a pure complex number, so it has only I stuff in it. We can put it on a 2-dimensional coordinate plane and then do geometry with it, and it actually turns out to line up perfectly with the properties of I.